Hey everybody! Sorry about class getting canceled. Kind of weird. Snowmageddon, now Meltamageddon. At any rate, this video is to accompany some assessments that I've put up for this Friday. Now, that seems a little bit quick. I like having more of a turnaround on assessments, but one of them was going to be a warm-up for today anyway. So it's pretty much self-paced. And that one in and of itself can take care of itself. It was the one where I had you draw cards in class, and for some strange reason to me you all got really upset. The deal was you pull cards out of the deck, and as soon as somebody pulls a red card, y'all can go home. And you pulled 5 black cards in a row, and everybody got all upset at my deck. Can I see your deck? Your deck's rigged. You know, but it's totally possible to pull 5 black cards out of a fair deck of cards. The purpose of that warm-up is to analyze whether or not you should have been upset at the seeing of 5 black cards. Now, hopefully you remember doing that. It was a long time ago. It was a week and a half ago, honestly. But to give you a review, the deal was, well, you know what? The warm-up actually does it pretty. I'm not going to, you can read the warm-up. It's all in there. So that's a little 5-point warm-up. We'll count that for the warm-up for Monday of next week. So you'll get a warm-up for that, that class. The second part of this video that I want to do kind of briefly is to introduce the in-class quiz that I was also going to do on the idea of confidence. So confidence is this term. Now, we've been talking about it for a bit now. Well back into 243, it crept into 243. It didn't creep in much. It crept in most in the beginning. I did that mostly for the 243 folks that were not going to take 244, but now here you are in 244, so I want to look at it more deeply and more intently. So here's the big idea. The big idea. Generally speaking, a statistician wants to know something about a population. And in particular, he or she wants to know a measure of the population, which is called a parameter. Now, that parameter can be one of many different kinds. It can be an average, it can be a percentage, it can be a median, it can be lots, and we'll talk in this class about them quite a bit because that is kind of a chunk of this class. The problem is the only way to get a parameter is actually to measure the entire population. So in other words, suppose you wanted to know the average rate of ADD in the US teen age range. Well, the only way to know that is to actually go and measure every single US teen, and that's impossible, right? So when you think about a population, the population is huge. I mean, that's not a very big rectangle, but you get the idea. It's a big thing that you don't have access to the entirety of. This is why I wouldn't let you see my deck of cards on the first day of class. The deck of cards represents, it's right here. It's right here. That is your population. So you can't look inside of it. What you're allowed to do is to get a sample drawn from it. So statisticians go in here and randomly draw elements of this population. And they pull those observations out into a sample. So, in other words, back to our example of teen ADHD rates, they might pull, you know, I've got 6 here, but they might pull 20, 30, 100, 1,000, 10,000 teens that from that population of teens they're interested in. And they might check those teens to see what % of them have that characteristic. And that's not called a parameter, though. That measure is called a statistic. Now, we've talked, that was part of 243, which you may have forgotten, and that's okay. Part of the reason this video exists is in existence. So you want to know a parameter of a population, but you only have access to the statistic in the sample. Now, something you, generally speaking, we learn in 243. We ran out of time last term, and that's okay. We're going to do it again. We're going to do it again in 244 next time I see you in class. Hopefully that's Monday. But here's the good news. In general, the statistic you get from your sample, assuming that you did a good random sample, that statistic you get from your sample is pretty close to the parameter in the population. So observation A is that generally your statistic is approximately equal to the parameter you're looking for. Now there are some caveats to this, which we'll deal with in class on Monday, promise. But the one I'm going to have you dealing with in your in-class confidence quiz, is true. The statistic you get on average is going to be approximately equal to your parameter. The problem is it won't be exactly equal. It won't be exactly equal. Pretty close is not exact. Now, pretty close might be good enough, but that argues the point, what is pretty close? If you ask 10 different people what pretty close is, they might give you different answers. So for example, back to our rate of ADHD. Some people might say, well, it has to be within 1% of the true value. And some people would say, that's far too restrictive. It could be within 5% and I'll be happy. And somebody else might say, that's ridiculous. Within 10% will be. So rather than get down that philosophical road of how close is too close, that's where confidence comes in. Confidence allows you to take your statistic and apply what's called a margin of error to the statistic that makes up for this offness that exists here. So yeah, the stat won't be exactly equal to the parameter. However, if we can construct this thing called a margin of error, which I've been calling MOEs. You'll see that a lot in your assessments. This is key. If you can construct a margin of error, that gives you wiggle room around your statistic. That gives you wiggle room around your statistic. And that should, with the idea of confidence tied in, allow you, on average, great successes in finding what the parameter is. Here's what I'm talking about. So what you do, here's the process, generally speaking, statistically. You want to know something about the population. You want to know a parameter measure in particular. You grab a sample. From that sample, you get a statistic. Now, you don't stop there. The media will stop there. They'll say something stupid like the statistic equals the parameter. A statistician, yourself included, will say, I've got a statistic. I've got a sample statistic. I now must construct my margin of error. And what you then create is called a confidence interval. And a confidence interval it's mathematically simple. It's not intuitively simple, but mathematically it's simple. All you do, and I call these CIs just because we use these terms so much, CI, confidence interval. What you do is you take whatever your sample statistic is and add and subtract from it the margin of error. So what you've done is you've got the sample statistic, which is pretty close, quote unquote, to the parameter. But then you make it better by adding and subtracting the margin of error to the sample statistic. Now by doing that, you go from having a single value called the statistic to having a range of values. And the beautiful part of this, let me see, I'm going to have to clear a little space. I'm going to clear it up here, just to clear us a little space here. Looking at it differently, this is one way confidence intervals are indicated, statistic plus or minus margin of error. Another way of looking at it is the statistic minus the margin of error, is the low end of an interval of numbers. And the statistic plus the margin of error is at the high end of the interval of numbers. Now in the in-class quiz I mentioned something called a UCL and an LCL. These are somewhat technical terms. LCL is called the lower confidence limit. It's just this number. And the UCL is the upper confidence limit. It's just that number. So what you've got is you've got a range of values. What is hoped, and that's where confidence comes in. And the word hope sounds like faith-based math, and it's not. Trust me. Trust me. One day you'll see how confidence ties to this idea of hope. What is hoped is that the parameter you're looking for from the population, we know it won't be exactly equal to the statistic, but we are confident that that parameter will be between these two values. We are confident that that parameter will be between these two values. We don't know exactly where. It might be far left, it might be far right, it might be close to the middle. On average it will be. But in any particular study, you grab a confidence interval. It's got a low end and a high end. That low end and high end represent the endpoints that you are confident trap the parameter. I want to tell you a really bad joke to wrap this whole idea up. 3 statisticians go bear hunting in the woods. 3 statisticians go bear hunting in the woods. And they're standing behind a log and they see a bear. First one jumps up, takes a shot, lands 5 meters to the right of the bear. Second one jumps up, takes a shot, lands 5 meters to the left of the bear. The third one jumps up, we got him! Worst joke ever, but exactly the point of a confidence interval. A confidence interval does not intend to hit exactly the parameter with the statistic. It aims to trap the parameter between two numbers. And the confidence is how frequently we are going to do that. And that's where your quiz comes in. I think that's enough of an introduction as far as what the quiz is having you do. So I appreciate your flexibility with this goofy time we're in the middle of right now with class getting canceled. Shoot me an email if none of this stuff makes sense, or if any, I'm sure some of it will make sense. If anything in particular between now and Friday doesn't make sense, or in general, when something doesn't make sense, just email me. Okay? We'll talk to you soon. Stay warm, dry, safe, crazy out there. Be well. Talk to you.